Similarly, if you have calcium carbonate which is heated up, it will break into calcium oxide and carbon dioxide, carbon dioxide and calcium oxide. It will break down. ठीक है? Let's talk about the combination of hydrogen and oxygen. What do you think happens? When you pass electric spark in a container and you have hydrogen and oxygen, they combine to create water. So some initiation is required. If you have methane and oxygen, combustion happens.
Yes, sir.
Ignition, आग लग जाएगी जैसे पेट्रोल के सामने मार तो. Some need an initiation, some happen all by themselves, but both will be called as spontaneous process. But if there is a process which does not take place by itself or does not even take place by initiation, such a process will be called as a non-spontaneous process.
Okay.
Agreed?
हाँ जी.
Example, flow of water up a hill, not possible. अपने आप नहीं होने वाला. Initiation से भी नहीं होने वाला, वापस आ जाए.
पंप की तरफ पहुंचा सकते हैं.
हाँ हाँ वो ठीक है. Dissolution of sand in water will not happen. It's not a spontaneous. There is no tendency also. Salt की tendency है water में अपने आप घुलने की. Sand की कोई tendency नहीं है अपने पास. And when it comes to the why some processes are spontaneous and why some processes are non-spontaneous, right? So the force which is responsible for the spontaneity of a process is called as the driving force.
Okay.
By why certain processes are spontaneous? They are because there exists a driving force. Okay, if you have a stone which falls down, what is the driving force which brings it down?
Gravity.
Yes. So you have certain minimum energy available to you and you fall down. Water flowing down, etc., etc. And if you take a spring and you twist it and you leave it, that it'll unwind itself, right? Because it would like to keep in a lower energy state, not in a higher energy state. Or if you keep a spring compressed and you leave it, it comes back, right? Which means it is again a situation of a driving force being available, generally in the form of a stored energy, some potential energy, some kinetic, some potential spring energy.
Spring.
Yes, you can say that. Okay. Heat flows from a hot body to cold body. Why? It's a spontaneous, right? Because of this, the heat content of the hot body goes down. Hot body ko benefit, right? There is a driving force inside it. Because it says my energy will become, I want to go in lower energy state. I will reduce my temperature. So hot body will spontaneously send out. So there has to be a driving motivation for a spontaneous process to happen.
Okay.
So burning of petroleum. Why is it spontaneous?
Burning of petroleum.
Why is it spontaneous? क्यों फटाक से आग लगती है? क्या ड्राइविंग फोर्स है पीछे? Burning of octane, right? For example, C8H18 plus 25 oxygen gives you 16 carbon dioxide plus 18 H2O2. And delta F H naught is equal to, मैंने हिंट भी दे दिया आंसर.
Combustion.
No, that is a process, right? But question is, why is it spontaneous? What is the driving force? Combustion is happening of the petrol. Do you see the sign of delta formation?
Okay, it's high
Why?
negative value.
That means the product side is at lower energy.
Okay.
Petrol is very happy to lower its energy. Any system would like to lower its energy. So it says मेरे को जलाई दो, and then reactant minus product, the energy difference is 10,951. तो क्या आएगा ना, जलाओ फिर मुझे, मेरी तो एनर्जी जलने के बाद बहुत कम हो जाती है. I become a lower energy system. So I would like to become carbon dioxide and water, because for every mole of octane which is burned, my energy gets lowered by this much quantity. बहुत अच्छा है ना, जलाओ. Driving force है. So driving force is what? Everybody wants to be in the lower energy state. A spring which is compressed, and when you leave it, goes back to the lower energy state. A twisted spring starts unwinding itself because it isn't twisted, it is in high energy state. When it starts automatically unwinding, it lowers its energy. A water at the height, when you open the tap, it wants to come down because it wants to reduce its potential energy. So the driving energy or the driving force is the energy, and energy wants to be at a lower level. Okay?
Okay.
So that is one of the key criteria for spontaneity. But the counter question is, acha theek hai, everybody wants to be in minimum energy, so every reaction should be exothermic. Every reaction in the world should be exothermic. बहुत अच्छा है फिर तो. क्योंकि in every reaction, the exothermic reaction, the reactants will be at lower energy state.
Okay.
Agreed?
हाँ जी.
But there are reactions in the world which are endothermic. Then why endothermic reactions are feasible? वो होते क्यों है फिर? If you have water as a liquid, water becomes a gas, vaporization. What do you think happens in this? Water in liquid state becomes water in gaseous state. Why? Vaporization is spontaneous. But do you know what type of reaction is it? To convert liquid water into gaseous water, what does it take? 40 kilojoules per mole. Change of state, vaporization. It's an endothermic reaction. It takes energy and it becomes vapor. Why does ice become liquid? It is an
That's what.
endothermic reaction. It's an endothermic reaction. You need heat to convert ice into water. But it happens. Latent heat of fusion is there. पढ़ी होगी तुमने 9th में, वो इतनी होती है बॉइलिंग की, फ्यूजन की.
हाँ.
स्टेट चेंज नहीं होती, ग्राफ सीधा रहता है. Okay. Dissolution of salt in water, by the way, is also a endothermic reaction.
और.
Because it breaks na into sodium plus and
हाँ
chloride.
हाँ. वो अच्छा
But है
हाइड्रेशन
तो
में खाती.
so yes,
हाइड्रेशन में खाती.
spontaneous
ठीक.
spontaneous है जी. तो मतलब बहुत सारे प्रोसेसेस हैं, जैसे कैल्शियम कार्बोनेट डिकम्पोज हो जाता है हीटिंग पे. N2O5 also breaks down into NO2 and oxygen. So these are also spontaneous reactions. They're willing to happen, but the trick is, यार अभी तो हमने सीखा था कि everybody has a driving force, everybody wants to be at a minimum energy level. ये suddenly क्या हो गया कि you want to be at a certain lowest energy level, and you are now becoming endothermic also. So the criteria of minimum energy state, which we say decides the spontaneity, has limitations.
ठीक.
Octane burned down because it lowered its energy, right? The energy became minimum. तभी तो octane जली थी, जो example दिया मैंने. But it is not always true. If this process is spontaneous, We just heard of so many processes which are spontaneous but are endothermic. So the logic of spontaneity being attached to just lower energy state may not work every time. It has limitation because the counter is, okay, I'm telling you 5 more reactions which are endothermic but spontaneous. So the concept we were trying to build, that minimum energy state is required, or every system wants to attain it, a minimum energy state is the driving force for a spontaneity, is not true always. It has limitations.
ठीक है.
Second, there are certain reactions where delta H is 0. No endothermic, no exothermic. But the reactions are still spontaneous. So it is not just that exothermic reactions will be spontaneous. Even endothermic reactions turned out to be spontaneous, and some reactions are neither endothermic nor exothermic, are still spontaneous. Okay, let's take an example. CH3, ये 12th स्टैंडर्ड का है. C2 बहुत ही मतलब फेमस रिएक्शन है.
अच्छा,
इथाइल अल्कोहल.
एस्टरिफिकेशन है ना?
हाँ. यस.
अच्छा, ये इथाइल इथेनॉइड प्लस वाटर.
हाँ जी. This is delta H is 0.
ओके.
Still it happens. Still spontaneous. तो ये तो minimum energy is no guarantee always.
एक्सेप्शन
That
है
the
तो.
हाँ.
तो एक्सेप्शन हो गया
हाँ,
एस्टरिफिकेशन.
एक्सेप्शन है. 4 पहले भी एक्सेप्शन ही बताई है. वाटर का लिक्विड से गैस बनना भी एक्सेप्शन ही था. एंडोथर्मिक है लेकिन फिर भी स्पॉन्टेनियस है.
फिजिकल में भी एक्सेप्शंस हो गए.
हाँ. Okay. Say gas is there under compression. So you have a gas which is under compression, and you have a chamber connected to it where it goes and it expands freely. Okay. So it is free to go and expand. So this is also a spontaneous process, but there is no delta H involved. You have a compressed gas, and what you have is evacuated vessel, vacuum wala, and this is insulated from all the sides, so no energy is going in and out. बिल्कुल पैक्ड है. सिर्फ दोनों को जोड़ दिया, और जो खाली वाला टैंक था, ये वाला, this process of free expansion is also the process of delta H is equal to 0. क्यों? Q is equal to 0 because this is insulated, totally insulated, and work is equal to P delta V. Now, since it is free expansion, no work is also done because this was evacuated. The vacuum में था. Gas is entering into vacuum. If it expands in vacuum, no work is done. Work is 0. W is equal to 0. Work is 0 because, sorry, Q is equal to 0 because this is insulated. So what is delta U going to be?
क्या लिखा है?
Delta U.
नहीं नहीं, एक मिनट, ये क्या लिखा है? ये 0 प्लस हो.
0 plus 0, दोनों ही 0 है. Q is 0 because it is insulated. Insulated and dono. No heat exchange here also. Even in expansion, no heat exchange. W is also 0. So both are 0. So though you can see the reaction is spontaneous, I mean, the process of expansion is spontaneous. When an ideal gas moves into vacuum, there is no heat exchange taking place. No heat exchange in this process, but it is still spontaneous.
Okay.
Now look at the, okay, let's talk about a situation. So endothermic, no heat exchanged, both are spontaneous. एक्सोथर्मिक तो कॉमन सेंस है कि स्पॉन्टेनियस होना चाहिए जी, लोअर एनर्जी होगी, बट जरूरी जरूरी नहीं. लेट्स टॉक अबाउट रिवर्सिबल रिएक्शंस. Reversible reactions are happening on in both the sides. Hydrogen gas plus iodine gas is resulting in formation of 2HI gas. And simultaneously, at a certain point, when there is a bare minimum some number of products available, they start breaking back into the reactants. Reverse reaction also happens.
Okay.
So when this reaction happens, the delta H is positive. Energy is absorbed. And when this reaction happens, energy is lost. Delta H is negative. Reverse लिख दिया. We've already studied Lavoisier law. So, but both are occurring simultaneously. Reversible का मतलब यही होता है. एक level of जब reactants react करके एक level of 2HI पे पहुंच जाएंगे, वो 2HI आगे बनना बंद हो जाएगा. और वो अगर बनाओगे तो वापस टूट के वापस H2 plus I2 वाली साइड पे वापस जाने लग जाएगा. Such reactions are reversible and they have both. On the forward side you have positive and the other side you have negative, and net change, energy change in the reaction, which is thermochemistry part of it, which we study from enthalpy, the first law of thermodynamics, is zero. Since there is no change in the reaction heat content of the overall reaction, but still it is spontaneous. होता है, नहीं तो फिर मिनिमम एनर्जी के लॉजिक से तो होना भी नहीं चाहिए था. ठीक है.
ठीक है.
So can we conclude that the energy factor or the enthalpy factor cannot be the sole criteria for deciding the spontaneity of a reaction?
True.
Heat
True.
change, true, right? Simple. So the
Hmm.
enthalpy factor cannot be the sole criterion for predicting the spontaneity or the feasibility of a process. तो कुछ ना कुछ तो बात होगी इंथैल्पी के अलावा जो तय करती होगी कि बेटा स्पॉन्टेनियस होगे कि नहीं होगे. आप
ठीक है.
इंथैल्पी तो इट हैज फेल्ड अस. इट इज गिविंग
धोखा दे दिया.
कॉन्ट्राडिक्टरी रिजल्ट्स. हैं?
धोखा दे दिया.
धोखा दे दिया. एग्जैक्टली, यू कैन से दैट इट टर्न्स आउट टू बी समथिंग व्हिच इज यू कांट रियली डिपेंड ऑन इट. कभी कुछ हो रहा है, कभी कुछ हो रहा है, तो कोई कंक्लूजन नहीं आ रहा. दिख रहा है कि किसी भी डेल्टा एच के केस में जीरो, नेगेटिव, पॉजिटिव सब में स्पॉन्टेनिटी है. सो ये तो पक्का हो गया कि देयर इज समथिंग व्हिच इज इनसाइड दिस सिस्टम which is more of a driving force, that is the capacity or capability of deciding whether or not the reaction will be uh, spontaneous or not.
और
Let's
वैसे
हाँ,
स्पॉन्टेनिटी क्यों पढ़ रहे हैं, मतलब इससे क्या यूज होता है?
इसीलिए बिकॉज See, we want to find out why some reactions happen. First law of thermodynamics was not able to explain us. The
Okay.
limitation of first law is it only talks about heat exchanges but fails to tell us why certain reactions are spontaneous and why certain reactions are not spontaneous. Hope it is clear in your mind. Why are we studying this? We are indirectly moving towards entropy, which actually will turn out to be the real factor which is going to decide the spontaneity. So the second factor we will study now, okay, is what? It is the second factor. Enthalpy पे हमने काफी विचार कर लिया, सोच लिया, discuss कर लिया. The second factor now is the tendency for maximum randomness. Randomness, which means if you have a process where you find delta H is 0, then you say, okay, enthalpy has no role to play here. मतलब spontaneity decide करने के लिए. Let's study something like a phenomena like mixing of two gases. Okay, the mixing of two gases which don't react with each other. Now they're enclosed in two containers, and you connect them and you open the wall between them. Okay, and you open the wall between them. Now, when you open the wall between them, what happens? Automatically, the two gases mix, right? Diffusion. क्या होता है फिर?
मिक्स हो जाती है.
When they come together, the disorder of the system goes up.
अच्छा.
It becomes more disorderly.
Okay.
There is more randomness in the ना heat exchange तो ही नहीं. फिजिकल लेवल में मिक्सिंग हो गई बस. ये गैस यहाँ थी, ये गैस यहाँ थी, डिफ्यूज हो गए, एक दूसरे के अंदर मिक्सचर बन गए. क्यों बना? कोई हीट चेंज नहीं है, कुछ डेल्टा यू नहीं है, कोई वर्क डन नहीं, कुछ नहीं, वैसे ही मिक्स हो गए बस. क्यों हो गए वे मिक्स? What you notice is that the disorder of the system has gone up. And this disorder is something we will now focus on. The randomness, the disorderliness of the future state, which is when the gases mix each other. Okay, let's talk about is one more example. If you have a situation where there is a ink, right? And this ink is in a beaker filled with water, and you put some ink on it. What happens to the ink?
Ink, water, पानी ब्लू हो जाता है, मिक्स हो जाता है.
क्यों? डिसऑर्डरलीनेस बढ़ती है सिस्टम की, रैंडमनेस बढ़ती है. पढ़ा रहे ना आपने, दिखता नहीं बादल जो ऐसे जाते हैं अंदर, स्प्रेड्स gradually, slowly. No heat exchange, nothing, but the randomness or the disorderliness of the system increases.
Spontaneous process है.
Yes. Any process in which the randomness of the future state after the mixing, etc., will go up. And that is an underlying hidden reason why, even though this type of reaction is there, heat exchange is so and so, but still यार ये हो रहा है क्योंकि actually
Enthalpy के
system
point of view से
नहीं हो रहा, नहीं होना चाहिए.
नॉन स्पॉन्टेनियस है.
Yes. लेकिन कुछ dominating factor है जो कह रहा है फिर भी होऊंगा मैं, वो है ये tendency of randomness. So can we say that the second factor, which is responsible for the spontaneity of a process, is actually the fact that every system then also wants to acquire maximum randomness.
Yes.
The system doesn't only want minimum energy. There is another overarching, more strong factor which decides whether the reaction. It is every system wants to acquire more randomness. जितनी ज्यादा इंक और पानी मिक्स हो जाएंगे उतना रैंडम सिस्टम बन जाएगा. भाई क्या है ये, पता नहीं यार, कुछ मिक्स हो गया अभी. लेट्स एक्सप्लेन. फॉर द एंडोथर्मिक रिएक्शंस हमने पढ़ा था पानी जो है वेपरस स्टेट में कन्वर्ट हो जाता है, राइट? सो लेट्स से यू हैव एन एंडोथर्मिक प्रोसेस. endothermic process. And this endothermic process is water in liquid state, which wants to convert into water into vaporous state. And this happens automatically. You don't do anything. बस पड़े रहने दो. थोड़े दिनों के बाद पानी उड़ जाएगा उसके अंदर से.
और
It's
वो
an
हीट भी तो
endothermic
आती है उसकी
process.
सनरेज.
हाँ, मतलब वो तो
बट
ठीक है. बट ये है स्पॉन्टेनियस ही.
ठीक है.
सनरेज का मतलब है एंडोथर्मिक ही हुआ ना, एनर्जी ले रहा है ना.
हाँ जी.
मिनिमम एनर्जी में तो नहीं जा रहा है. ये भी हो जाता है फिर भी. वाई?
एंडोथर्मिक है ना
बिकॉज
ये.
हाँ, एंडोथर्मिक है. बट the randomness which water gets in vaporous state is very good. The water in vaporous state as compared to water in liquid state, molecules of the vaporous state are more random.
ओके.
यार ऐसे ऐसे हवा में उड़ते रहेंगे ना, वो तो कहीं भी
हाँ हाँ.
रैंडम है. लिक्विड के तो पड़े हुए हैं ना, जुड़े हुए हैं आपस में.
हाँ जी. वो एटम्स भी स्कैटर्ड ही होते हैं.
Yes. So tell me, why melting of ice is more random? Is it, will it result in more randomization of water
नो
molecules,
नो नो
or
नो.
why melting of ice? Why
मेल्टिंग ऑफ आइस,
melting?
यस. फ्री.
Yes, yes,
एंड
yes, of
रिवर्स ऑफ
course.
दिस वुड नॉट.
No, definitely. Melting of ice is also a spontaneous process.
हाँ जी. बट सर इसका रिवर्स क्या होगा? वो नॉन स्पॉन्टेनियस हो गया या वो
Yeah,
स्पॉन्टेनियस ही होगा?
entropy will be negative for that. Yes, non-spontaneous.
ठीक.
Okay, now you dissolve ammonium chloride in a
हम्म.
solid. Okay, now why is it a spontaneous process? It is a endothermic reaction, dissolution of ammonium chloride in
उसको
water.
कुछ तो
Because
इसका नाम है शायद इस रिएक्शन का.
वो नहीं, ये जो NH4Cl होता है वो आयनिक स्टेट में चला जाता है, राइट?
हाँ हाँ. वो तो अच्छा वो हाइड्रेशन
एक्वस.
एंथैल्पी की वजह से.
हाँ, aqueous. These are more random if they are inside water. Ionic state is more random than the molecular state, solid ionic state, crystal state. So the process is accompanied by increase of randomness. So more is the randomness, the more is the tendency of the body to acquire it. That means every system also wants to, has a tendency for maximum randomness. Okay. So if there is a example which is solid mercuric oxide, okay, this also decomposes and it becomes liquid mercury. This also is and some oxygen. Okay, solid mercuric oxide होता है. क्या लिख दिया? Solid mercuric oxide
रैंडमनेस
becomes
बढ़ रही है.
randomness.
तो ये एक स्पॉन्टेनियस प्रोसेस.
Yes. Now we have a sense that here, apart from enthalpy, there is another factor which is deciding the spontaneity, and that is acquisition of maximum randomness. Now let's discuss what are the limitations of this thinking. इसकी भी limitations है.
यार.
ठीक है. So जैसे कि डेल्टा एच की लिमिटेशन थी पिछले में, उसी तरह से डेल्टा एस की भी लिमिटेशन है. इसका मतलब है देयर आर गोइंग टू बी सर्टेन प्रोसेसेस where the randomness is not going to increase, but they will still happen.
तो मुझे लग रहा है पूरा थर्मोडायनेमिक्स गलत प्रूव होने वाला है अब तो.
नहीं नहीं नहीं, थोड़ी सी वो दे आर क्रिएटिंग सम, क्या बोलते हैं, संदर्भ
सस्पेंस.
बना रहे हैं कि दे आर क्रिएटिंग अ कॉन्टेक्स्ट कि देखो हिस्ट्री ऐसे डेवलप हुई थी इसकी, ऐसे ऐसे सोच बनी थी. तो लेकिन फाइनली what are the driving forces for a process? Combination of tendency to acquire minimum energy and tendency to acquire maximum randomness. These are the two factors which are very solid factors towards the process of deciding spontaneity or not. So दोनों का combination. Okay, so let's say no, there is a process where you do liquefaction of a gas. LNG gas आती है, liquefied natural
बट
gas.
नहीं लिक्विफाइड एलएनजी या फिर एलपीजी?
हाँ, समथिंग LNG भी तो होती है
अच्छा,
नेचुरल.
मैंने एलपीजी सुनी है, लिक्विफाइड पेट्रोलियम गैस, जो घर में आती है।
CNG होती है फिर वो, सॉरी.
हम्म, हाँ वो शायद वो होती है, वही
हाँ, वो होती है. यस यस.
कंप्रेस नेचुरल गैस।
हाँ. यस. हाँ, नहीं, LNG भी होती है. द गैस
नहीं,
इज
मैंने
कूल्ड
मतलब कह
डाउन
रहा
टू
था
लिक्विड फॉर्म.
एलपीजी सुनी थी।
है.
मैं तो एलपीजी सुनी थी।
हाँ, वो ये होती है C2H6 और मिथेन, और इसकी मिक्सिंग होती है और उसी से बनाते हैं नेचुरल गैस से. सो ये कतार जो है, कतार इज अ वेरी बिग सप्लायर ऑफ LNG टू इंडिया अभी.
ओके।
तो एनीवे, साइड्स द पॉइंट, कुछ हो गया था. तो if you look at liquefaction of a gas by, or solidification of a liquid, for example turning something into an ice, right? अगर रैंडमनेस के लॉजिक से जाया जाए तो आइस कैनॉट बी सॉलिडिफाइड.
फर्दर सॉलिडिफाई नहीं कर सकते।
कर ही नहीं सकते ना, रैंडमनेस तो बढ़ नहीं रही, घट रही है. तो कंक्लूजन
जैसा
ये
होता होगा
निकला
सुपर
कि,
सॉलिड्स वगैरह।
हाँ, तो कंक्लूजन क्या है? कंक्लूजन है कि यू हैव टू फैक्टर्स विच आर गोइंग टू डिसाइड द फेट ऑफ स्पॉन्टेनिटी. ये है हमारा. सो देर आर टू ड्राइविंग factors. One means the tendency of the system to acquire least energy, and second, the tendency of the system to acquire maximum random. So there are two driving forces actually, जो drive करेंगी क्या होने. Let's say एक process लेते हैं. Okay. So let's say there is a process and this is from A to B. Okay. Now E represents the tendency for minimum energy.
ठीक है।
Okay. R represents the tendency for maximum randomness. ठीक है. E, R, D, and D represents the overall tendency. E, R, D तीनों है, और D is the net, the outcome of both the tendencies. कि होगा कि नहीं होगा. If E is wanting to happen and R is also favorable, then D will happen, right? Both want to happen. Both are in your favor. Randomness is going up. Energy is also wanting to go down. Very favorable. So D is equal to E plus R.
ओके।
Let's say there is a process जिसमें enthalpy का बहुत अच्छा ड्राइविंग फोर्स है, लेकिन randomness में ऑपोजिशन है. तो नेट रिजल्ट क्या होगा? हो जाएगा. ये एक
ये
मिनट
हो
एक
जाएगा।
मिनट, क्योंकि एक फैक्टर बहुत प्रीडोमिनेंटली स्ट्रांग हो गया. Let me redraw this. I think I've drawn it at the wrong level because this is, sorry यार, क्या बन रहा है? Enthalpy factor is very strong. Randomness factor is oppositional. It doesn't want the system is not able to attain maximum tendency. But because E is very strong, still it happens. Subtraction. E wins the game over randomness. Third situation, both are unfavorable. Or say randomness is stronger than enthalpy. सो इंथैल्पी को मैं बना रहा हूँ सबसे पहले उल्टा. It is endothermic or maybe zero, but randomness acquisition is very high during the process. So R will dominate now. So the reaction will happen. थोड़ा सा लंबा इसको कर देते हैं. It's a difference in R minus. So D is R minus. Three situations. So you can see the driving force is net forward. पहला केस है, the driving force is net forward. ठीक है? Let's move to the next one. Okay, so what do you think the first and second are? First and second reaction कौन से? Exothermic, right? Exothermic means the system automatically wants to acquire lower energy. This is
Yes,
endo.
sir. Yes, sir.
So these are anyway exothermic. तो पक्का ही है इसके बाद. Let's do another thing. Let's do a reverse thing. So this is type 1 driving force. The net is forward. So this is type 1. Type 1, sorry. Okay, let's talk about type 2. Type 2 के अंदर let's focus on one thing. Now the type 2 is when the net driving force is in the backward direction. Okay, so let's say the situation E, R, okay, both states, what will happen? The reaction will happen in which direction? Spontaneously, backward direction.
ठीक है.
They add up. Now E is very happy being here, but the randomness of the system in backward direction is very high. So the reaction will happen, but it will happen with the difference in both the. तो ये E है इस तरफ, लेकिन randomness रिएक्शन को बोलती है पीछे की तरफ रिवर्स हो जाता. तो नेट रिएक्शन जो होगा वो R माइनस E हो जाएगा. तीसरी सिचुएशन में द E R और उसके बाद नेट इज रिजल्टेंट. तो इधर रिवर्स होने के लिए जो तैयार बैठा है वो है ये वाला रिएक्शन. और ये रैंडमनेस वांट्स टू अटेन बट this is reverse. So first and last, if you notice, this one and this one, you can see these are type 2. इसमें भी ये वाला रिएक्शन भी होगा क्योंकि इसमें enthalpy dominates in the backward direction. So these are the ones which happen in backward direction. This is D is equal to E minus.
Okay.
ठीक है जी. Now look into these cases. We'll come to them. So what does this tell you? Both E and R are oppositional. They don't want the system to go forward. Both are oppositional.
Okay.
Forward direction में वो नहीं चाहते. तो ड्राइविंग फोर्स बैकवर्ड ही. इसमें if you notice, the E favors the reaction in spontaneous direction, but R is oppositional. Second situation, इसकी बात कर रहा हूं मैं. बैकवर्ड में तो R is
Okay.
greater than E. तो फॉरवर्ड डायरेक्शन में कोई ड्राइविंग फोर्स है नहीं होने के लिए स्पॉन्टेनियस.
ठीक.
Let's talk about the last one. The last is E is very oppositional. It doesn't want the spontaneous reaction to happen. But R supports the spontaneity. Randomness बढ़ती है forward direction पे. But R is supporting.
ठीक है।
तो ये रिएक्शन जो हम बात कर रहे हैं अभी, व्हाट आर
हम्म।
दीज रिएक्शंस? ये वाला रिएक्शन, ये और ये
नॉन
एंडोथर्मिक,
स्पॉन्टेनियस, मतलब
एंडोथर्मिक,
एंडोथर्मिक, सॉरी।
एंडोथर्मिक रिएक्शंस।
कि हीट यूज हो रही है इनके अंदर।
हाँ, एंडोथर्मिक रिएक्शंस है। और इसमें तो ये एंडोथर्मिक भी और रैंडमनेस भी नहीं हो रही।
ठीक है।
सो विल दिस रिएक्शन हैपन? ये रिएक्शन भी नहीं होगा, ये रिएक्शन भी नहीं होगा, ये भी नहीं होगा। व्हेन आई से बैकवर्ड डायरेक्शन, आई मीन द स्पॉन्टेनिटी इज नॉट देयर। अगर आप जो भी रिएक्शन बोलोगे ये होगा, अगर उसमें ये सारे ट्रू हो गए तो आप बोलोगे नहीं ये नहीं होगा, इसका उल्टा ही होगा।
ठीक है।
ओके, टाइप 3 लेते हैं जिसमें ड्राइविंग फोर्स ही जीरो है। ड्राइविंग फोर्स is zero. So driving force is zero. So E is very favorable. Randomness is oppositional, equal. जितना वो होना चाहता है वो उतना नहीं होना चाहता। नेट ड्राइविंग फोर्स जीरो। जितना ये नहीं होना चाहता उतना ये होना चाहता है, रैंडमनेस। तो जो गेन आना था रैंडमनेस से, इट इज लॉस्ट बिकॉज द रिएक्शन एट एंथैल्पी फ्रंट लूजेस। So D is again equal to zero. So all these processes which are backward shown actually mean that forward spontaneity is not there. जो होना होना आपसे पूछा जा रहा है उसके उल्टा ही होगा सब। तो these are non-spontaneous. A, B, C, D, and E. All are non-spontaneous. They are not feasible. नहीं होंगे। दोनों ने करके देख ली लड़ाई और देखा जो बैकवर्ड डायरेक्शन के अंदर है सारे के सारे। सो what we want for a reaction to be spontaneous and happening is the driving force has to be forward always. If you have a backward driving force, such a reaction cannot be a spontaneous reaction. What say? Clear?
यस सर।
Okay. Let's discuss now one example. Let's talk about, because this is probably, I think, very easy one to understand. Evaporation of water. Very, very endothermic. So E is
हाँ जी।
oppositional, right? E is backward.
हाँ जी। बट ये तो वैसे भी स्पॉन्टेनियस ही है।
हाँ, क्योंकि भाई अभी हमने आर भी तो देख रहा है, रैंडमनेस। रैंडमनेस फेवरेबल, तो नेट हो गया था, हो जाता है ना ये आराम से वेपराइजेशन। तो इसका मतलब आर माइनस ई, आर इज फेवरेबल, आर विंस ओवर। सो डी इज ग्रेटर देन जीरो।
ठीक है।
ओ माय गॉड, सो मच फॉर योर concept of driving force.
ठीक है।
5 minute break.
ठीक है सर, मैं
Okay, time up.
Yes. Just a minute.
Okay, no problem.
Yes, sir. Yes, sir. I'm back.
All right. Now we will do some. So before we start the concept, so let's say if we mix H2 plus O2, okay, but they don't are not created in an electric tube. So the conditions are not there. There are two gases that only mix. Tell me whether this reaction appears to be spontaneous or non-spontaneous.
Um,
अभी combine
non
नहीं हुए
non spontaneous.
because they have a tendency inside it, right?
हाँ
Because
जी.
if you give it electric spark, it will result in formation. So initiation, right? Urge, the tendency is there. Just the factors are absent, right? It is spontaneous because there is it can be initiated by something, and that initiation is the electric spark. ठीक है?
Okay.
Just a so we are gradually what we're doing is we are moving towards understanding of entropy.
ठीक है.
True or false? An endothermic process. Okay, let me share the statement. You tell me true or false. पूरा ही आंसर आ जाएगा बेटा. नहीं वो तो खैर वही था. True or false?
True.
Yes, very much.
क्योंकि वो एक्सेप्शन भी थे ना. क्या
Yes, very much. It is. Okay, true or false? Hello.
False.
Read it very carefully, friend. Don't be in a hurry. If you have favorable condition in one direction, then so be it, right? Why will you go back? Why will you be non-spontaneous? This is
हाँ.
true. They are non-spontaneous.
ठीक. Okay.
Do you think spontaneity depends on temperature and pressure
Spontaneity depends on temperature and pressure.
of the conditions? So, for example, let's say, let me show you a very interesting case. Though we are not studying it right now because we have not entered into that area, but just for the sake of understanding, see a situation. How spontaneity gets impacted. अब मस्त चीज है देखो.
क्या है उसी?
Let me show you.
और
If the temperature is greater than zero, ice melts.
आज. Okay. Okay. Got it.
But it is spontaneous in reverse also. If it is T less than zero, then water also becomes that.
बट एक मिनट. पहले आप कह रहे थे कि अगर फ्रीजिंग है तो ये नॉन स्पॉन्टेनियस है.
हम्म.
अब
मैं बोल रहा हूँ
स्पॉन्टेनियस हो रही है.
टेम्परेचर से स्पॉन्टेनिटी कैसे डिसाइड हो रही
तो स्पॉन्टेनियस डिसाइड ही नहीं होती फिर टेम्परेचर से. तो ऐसे तो
है. ये देखो ना उधर ही है.
मतलब है ही स्पॉन्टेनियस ही रहेगा, चाहे टेम्परेचर कैसा भी हो।
यार ये देखो ना, ice to water, if temperature is greater than zero, is forward in this direction.
एंड रिवर्स तो ये नॉन स्पॉन्टेनियस है ना?
नहीं?
ये दोनों में
See,
स्पॉन्टेनियस है।
no, but in the reverse, see the condition change.
स्पॉन्टेनिटी रिवर्स डायरेक्शन में।
But temperature को क्या हो गया?
कम हो गया।
Less than zero हो गया.
हाँ।
At temperatures which are less than zero, water immediately becomes ice. तो
ठीक है।
spontaneity की डायरेक्शन बदल गई ना टेम्परेचर के हिसाब से।
हाँ जी। यस।
Which type of process is it? Recognize.
रिवर्सिबल।
Yes. करेक्ट है। Okay. बताओ what type of process is this?
इरिवर्सिबल।
Irreversible. Irreversible. So what is the conclusion? If temperature dependence is forgotten, spontaneous processes are
रिवर्सिबल। रिवर्स।
irreversible.
इरिवर्स।
ऊपर पढ़ा था ना अभी हमने ये।
हाँ जी हाँ जी।
They are not spontaneous in reverse direction.
ठीक।
थोड़ा सा। Okay. Now let's come to our main topic. Okay. The measure of randomness of a system is called as entropy.
ओके। ठीक है। तो वैसे रैंडमनेस के प्रोबेबिलिटीज निकालते हैं क्या?
Randomness plays an
मेथड
important
कैसे?
role in probability calculation.
ये मतलब निकालते कैसे हैं? जैसे केमिस्ट्री में।
Randomness निकालते कैसे हैं?
यू बाय टी।
Yes. पहले उसका कॉन्सेप्ट समझ लेते हैं and then we go to the math. For a substance in crystalline state, it will have the lowest entropy, right?
जी।
Liquid state, midway. तो गैस सबसे ज्यादा रैंडम हुई ना एक सब्सटेंस के लिए. A substance in gaseous state is most random.
ओके.
So this is solid. You can see there is not much of a randomness. Look into this. So much gas. Random. Sorry, ये liquid है. अब gas आई. Most random. So this is increasing randomness. Like enthalpy, internal energy, entropy is also state function.
Is independent of thought.
Yes.
Independent depends upon the initial and the final state.
Yes. बीच में क्या क्या हुआ एंट्रोपी के साथ कोई मतलब नहीं. फाइनल एंड इनिशियल ओनली.
पहले मुझे पाथ फंक्शन लग रहा था. ठीक है.
सिस्टम का डेल्टा एस फॉरवर्ड है बैकवर्ड है. एस प्रोडक्ट्स माइनस read this very carefully the formula. So if there is a process that happens and they ask you please tell us कि इस process में entropy change क्या हुई है. Calculate the overall entropy of the products and subtract it from the entropy of the reactants. That will tell you the degree of disorder. What is the word?
Degree of disorder.
Yes. Randomness. किस extent तक degree? What is the degree to which the disorderliness is there?
Okay.
Okay. So if a system absorbs energy, the kinetic energy of the molecules will go up, matlab internal energy will go up. Alongside when they start moving, can we say that the randomness has gone up?
हाँ जी.
So can we say if you absorb heat, you become more random?
Yes.
Okay. Now let's say the same phenomena happens at a lower temperature.
Randomness would be low.
Okay. So the disorder will be more at higher temperature at lower temperature.
More at higher temperature.
Right. So which means disorder disorderliness is inversely proportional to temperature. Higher the
Yes.
temperature, lower will be the change in enthalpy.
हाँ जी.
दोबारा बोल रहा हूं मैं. If the heat is absorbed at low temperature, what will happen?
Heat absorbed at low temperature, the randomness would be low.
No,
Would
high.
be high. Sorry, would be high.
If the heat is absorbed at lower temperature,
हाँ जी. Okay. ठीक है।
Disorder
हाँ जी।
is more than at higher temperature.
ठीक है।
एक सेकेंड। What is a statement of first law of thermodynamics?
Yes,
Energy can be converted from one form to another, but cannot be created or destroyed. Law of conservation of energy and interconversion of energy.
yes, sir. Okay.
What is
ठीक
a
है।
measure of randomness or disorder of a system? What
डेल्टा
is the measure of randomness or disorder of a system?
द एंट्रोपी।
Yes.
ग्रेटर द रैंडमनेस
During
द एंट्रोपी।
during evaporation, the entropy increases. True or false?
ट्रू। द रैंडमनेस वुड बी हायर।
Yep. During the creation of a solution, the entropy is increasing. That is when solute and solvent get added, the entropy in the solution increases.
ट्रू।
Yes, absolutely true. Some processes, some the processes which are spontaneous at one temperature, fixed temperature, may be non-spontaneous at another temperature.
फॉल्स।
Okay. Other temperatures.
या।
True ना? Temperature बदला है ना, मैंने conditions बदल दी.
ओके।
Most of the exothermic reactions will be spontaneous.
यस सर।
Both are favored, enthalpy and entropy.
यस।
If the number of moles increases,
यस।
will the entropy change of that? जैसे आपने एक वो ले लिया, कंटेनर ले लिया, उसमें आपने गैस के ज्यादा मोल्स डाल दिए. That means you have increased the number of molecules in it.
यस सर।
What will happen to the entropy? Increase.
इंक्रीज।
More randomness. और जो मर्जी
और
होगा
द
आपका.
मोस्ट मोर द एंट्रोपी।
Yes. Higher the temperature, higher the entropy.
ठीक है। And less is the
Hold on, hold on.
temperature.
No,
What?
no, no.
Okay.
Higher the temperature, which means entropy will go up, right?
हाँ जी.
Higher the volume of the container, higher the entropy.
Yes. Because moles would be more.
Temperature, kinetic energy will be more.
Okay. ठीक है. अब कहते हैं इनवर्सली प्रोपोर्शनल होता है
No,
टेम्परेचर.
temperature, exactly. So now listen to this. If the heat is absorbed at lower temperature, then the disorder is more than at higher temperature.
ठीक है.
Absorption heat की हुई है, but temperature आपने lower कर दिया heat absorption का. If you absorb heat at lower temperature, then the entropy will be higher.
Okay.
ये लिखा हुआ है. So what are the two factors on which degree of disorder depends? It is directly proportional to amount of heat, but at what temperature do you absorb? That is inverse. This is not that, this is a temperature at which heat is absorbed.
Okay.
So S is equal to Q by T.
ठीक है.
But remember, ये वाली Q कब होती है? Isothermal.
ठीक है. No exchange of matter and energy. Sorry, temperature is constant. I'm so sorry.
Yes.
Temperature is constant.
T is fixed. तो पहले वो देखते हैं कि अगर हमने T को फिक्स रखा हुआ है तो हीट के अमाउंट से क्या फर्क पड़ता है. फिर उसी हीट को वो दूसरे टेम्परेचर पे एब्जॉर्ब करवा के देखते हैं क्या फर्क पड़ता है. तो देखते हैं अगर हीट को हम लोअर टेम्परेचर पे एब्जॉर्ब कराते हैं, लोअर, then the entropy is higher than that at higher temperature. So inversely, lower is the temperature at which you absorb the heat, higher is the entropy. So that T is a lower temperature at which you have absorbed. So in inverse, it's an extensive property.
ठीक है.
Okay. Entropy as a state function. So consider if you have a system that is cylinder, okay, it contains a lot of gas in it, and piston is there, and so piston is weightless, and it is placed in contact with a large reservoir. Okay, so you have a gaseous cylinder containing a lot of, and it is in touch with a large heat reservoir.
ठीक है.
Now, what will be the entropy change when you connect it? System is the gas, जो भी उसने Q receive करी,
ठीक.
and it is the heat reservoir, temperature is T. So it absorbs this heat isothermally. If it gains this heat, this reservoir would lose how much heat? Q.
Yes, sir.
So what is the change in entropy of the reservoir?
Q upon
सेम.
T.
जितनी हीट उसको मिली वो रिजर्वायर ने दी सिलेंडर को.
ठीक है.
So amount of entropy gained by the system. सिस्टम का मतलब है गैस इनसाइड अ पिस्टन. यहाँ पिस्टन लगा हुआ है. Weightless. So no work is being done. So now if we calculate the overall change in the entropy of the universe,
Is
zero.
0. QT minus QT.
Zero.
Hmm.
Now let's do one thing. Because the gas expanded during this time when it gained heat, it, for example, expanded from a volume of V1 to a volume of V2. ठीक है. So डेल्टा टोटल चेंज इन एंट्रोपी अगर आपको निकालना है, what will happen? Now you compress the gas. Second step. पहले आपने इसको एक्सपैंड करा था. This step was expansion
ठीक है.
from V1 to V2. Now it is compressing the gas from V2 to V1. What is the heat lost by the system? Entropy lost by the system. Volume is decreasing, so then entropy will decrease.
ठीक.
Minus Q by T. What is the heat which is absorbed by the reservoir? What is the change in the enthalpy of the system? इसका मतलब एक्सपेंशन हो और उसके बाद कंप्रेशन हो. The enthalpy change in both the process in a complete cycle of expansion and compression. ये सिलेंडर पहले एक्सपैंड होके यहाँ गया, एंट्रोपी गेन कर ली, नेट एंट्रोपी तो जीरो ही, और फिर आपने कंप्रेस कर दिया वापस. सो इफ यू नोटिस, if any time you get a cyclic process which undergoes like a cycle of expansion and compression, it's a cyclic process. It repeats itself again and again. जैसे कार के इंजन में cyclic process होता है. Then the entropy remains same. In cyclic processes, entropy remains same. But if you remember the work done in a cyclic process like this, there is an area under the curve, P versus V. In a cyclic process, work may be done, but it returns to the same position, so the internal energy is same at the back point.
Okay. Anything else?
No, that's about it. We will discuss entropy in detail tomorrow, and we will solve numericals on entropy tomorrow, and we will close this chapter for good.
And Gibbs वगैरह?
हाँ, उसके बाद yes, Gibbs भी कर लेंगे, हो जाएगा. We've understood entropy Q by T. Now we just need to know how to apply this and then extend into a law saying that let's bring together enthalpy and entropy together and create a law created by Gibbs. And then see कि Gibbs का जो net resultant law होता है, resultant of entropy and enthalpy, उससे हम कैसे decide करते हैं कि reaction will be spontaneous or not. Direct driving force की calculation.
Unification of entropy and enthalpy.
Yes, you can say that.